Okay, we will be looking at problem 1.40 on page 52. I will skip over reading the stem and advance straight to A. It says find the mean from its definition, that is, find the sum of the 6 observations and divide by 6. So, part A, we want to find the sample mean. We use the symbol X with a line over it to denote sample mean. We call this X bar. X bar is equal to the sum of each X observation, denoted by X sub I, divided by N, the total number of numbers. Again, X sub I is each observation X, 1, 2, 3, through the total number N. For our problem, X bar will equal the sum of the numbers, the first number being 5.6 plus 5.2 plus 4.6 plus 4.9 plus 5.7 plus 6.4. Divided by the total number of numbers in this sample, which is 6. So X bar is equal to 32.4 divided by 6, which is 5.4. Our sample mean, X bar, is 5.4. Okay, part B, sample standard deviation. We will use the symbol S to denote sample standard deviation. From our formula chart or from page 49, we can see that sample standard deviation is the square root of 1 divided by n minus 1 times the quantity sum of each observation X minus sample mean quantity squared. This formula can look a little bit intimidating in the beginning, but it's really not that difficult. This symbol sigma we've just seen previously. Sigma is sum of, that means we're going to be adding some things up. Xi is each individual X. X bar is the sample mean that we just calculated. And N is the sample size. We will see this pretty consistently throughout the year, N being the number of observations in the sample. All right, so let's look at how we'll use this formula. So I'm first going to calculate this term here, the sum of each X minus the sample mean quantity squared. The sum of each X minus the sample mean quantity squared. So our first X is 5.6. Our X bar from the previous part A, is 5.4. Quantity squared. This quantity, 5.6 minus 5.4, is 0.2. 0.2 quantity squared is 0.04. Now, I'm not going to calculate each one of these. I'll leave that to you. I will simply write plus, dot, 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 and then look at the final term. Well, our final observation X is 6.4. Again, subtracting our sample mean, 5.4, quantity squared. So plus, dot, 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 plus, 6.4 minus 5.4 is clearly 1. 1 quantity squared is 1. Adding up these two terms and the other 3 in the middle will yield 2.06. This 2.06 is this term here, the sum of each x minus sample mean quantity squared, which is in turn this term here. So now I must simply multiply by 1 over n minus 1. Stated another way is to divide by n minus 1. So now the sample mean becomes the square root of this term, 2.06, divided by n minus 1, in our case, 6 minus 1, or 5. 2.06 divided by 5 is 0.412. The square root of that is approximately 0.642. We will use this term most frequently for approximately and equal with a dot over it. You will also see a wavy equal sign, which you may be familiar with from previous math classes. Both of these meaning approximately. All right, so in summary, this again was S, our sample standard deviation. Sample standard deviation. It was 0.642. Okay. Finding sample standard deviation by hand. And I'm going to say by hand in quotation marks because essentially we may have used a calculator to find this square root. We may have used it to do some of this squaring, but we didn't simply type it into our list function and automatically come up with. We could have done this with a 4-function calculator as opposed to our graphing calculator. We're going to use a 5-step process. First, find x bar. That's our sample mean. Next, subtract x bar from each observation. Next, square each result and sum. Next, divide by n minus 1. Lastly, take square root. All right, I want you to practice this procedure with the following set. Find S for 1, 8, 4, and 7. Once you've done it by hand, use your TI-84 or TI-Inspire. Check and see if you got the correct answer.